Hello again, this is Tyson.
This is Nathan again, and we're going to be working through problem number 7 on the group work. So in this problem, we have, starting out, we have two charges, two electric fields.
One electric field.
One electric field with two
test charges.
Test charges.
Yeah.
And one of them is at 2 centimeters, and we find a magnitude of 500 newtons per coulomb there. And at 5 centimeters, we find 250 newtons per coulomb. And so we're going to show you how to find the charge of the electric field and the x position of where that point charge is located.
So the basic equation we'll be using is E with the vector equals K times Q over the radius squared with R hat. And R hat is just kind of a designator pointing the direction. So in each case here, the direction that the charge is pointing is in the positive x direction. We do want to note that K does equal 1 over 4 pi times E, or I guess epsilon naught, but that's too much to write, so we'll just use K. We're going to set up our first equation with charge number 1. We have R squared and Q and K. And then our second one with R equaling R plus 3, and that's squared.
So our R will come out and being measured from point 1, and we'll take account of that later. One thing you'll notice is that the charges are multiples of each other, so the second test charge is half of the first, and so we're going to use that relationship to create a system of equations that E1 is equal to 2 times E2.
And then so if we double the E2 equation, we get K times 2Q over R plus 3 all squared. And if we set these equal to each other, so this equation equal to this equation, we get these equations that are equal to each other. A lot of the terms nicely cancel out. And so we are left with 1 over R squared equals 2 over R plus 3 squared. For simplicity, we're just going to flip the equations.
Now we'll do some algebra here and rearrange the equation and solve for this equation in quadratic form so that we can see what's going on here. So we end up with negative R squared plus 6R plus 9 equals 0. And then solving for that using either Mathematica or the quadratic formula, we end up with R equals 7.2426 centimeters.
We do want to note that the second root is 1 point something, and if we think about it, that could work if the point was here, but because we know that the directions of the charges are both in the same direction, that our charge could not be between these. If it was between these, then this charge would actually be pointing this way, and this charge would be pointing in the same direction. Since they're pointing in the same direction, we know that the charge is somewhere over here. And so, because of that, we know that the x position of the charge is negative 5.2426 centimeters. And we kept it in centimeters just to keep it simple to convert to meters.
Okay, so that's the first part of this question. The second is we're going to find the charge, that point charge, using the information we now know from the distance that it has from our test charges. And so we're going to come back to our equation here and rearrange it to solve for Q.
Some of this kind of got messed up here. So this is supposed to be, something happened when we scrolled. So this is Q. And then this is our K, which is 8.99 times 10 to the negative, or sorry, not to the negative, to the positive 9 newtons times meters squared over coulomb squared. And that will come out to 10 coulombs.
So that is the charge of our field. And below there you can see our unit analysis to make sure that we are doing things right, and it does come out as coulombs. So
Part A and part B all together.